Anyone from, Middle East Asia, good evening, maybe good night, depending on where you are. And it's 6 p.m. here in Armenia, where I'm right now. So that means that we're about to start week 3 of Life After Code in Place to 2025. And as usual, we would like to welcome you all. Just as a reminder, my name is Alexander Belyakov, and also here is Vicky. Hey, Vicky, how are you doing? I only saw a silent wave of the hand, but here, as usual, we have another Calvin and Hobbes comic for you because Vicky is a big fan, and Vicky's always saying, "Don't you forget, to put in a bit of Calvin and Hobbes at the beginning." So this one I liked very much. Calvin saying, "What I lack in ambition, I make up for in absolutely nothing." So sometimes that happens. So week 3. Before we start, a very quick overview of the organizational notes we had in week 1 and week 2. So once again, this program, these sessions are not in any way sanctioned or endorsed by Code in Place or Stanford in general. So we're not giving out any certificates, recommendations, or job offers. And the important part is active participation in the process. So we're going to work once again in breakout rooms, and we're going to work together. And when we're all in one room here, I would ask to use the raise your hand option if you would like to participate in the discussion to avoid chaos of many people speaking at once. So if you have something to say, please raise your hand, and I will ask you to contribute. I'll talk about the assignment links for the next weeks in a couple of slides. The idea is that it's a lot more useful to go through the problems, the assignments in advance before actually coming to this session. This would be a lot more useful. We are doing recordings of this to be placed on YouTube later. And the important thing is, please note that we're not editing these YouTube videos for privacy. So if you do not want your name to appear or your face to appear in our videos, please change your name and turn off your camera if that is important to you. If you have any questions, you are always welcome, obviously, to ask them here. But if outside of our sessions, you can post them in the main forum. If you add LACIP at the beginning, we will see them faster. Of course, we ask everyone to be professional and behave nicely. And also, any questions, suggestions, or feedback, you can send it to the email that you see on your screen, carolcip2024@gmail.com. So that's basically the organizational notes. And now let's take a quick look at the schedule for the next 4 weeks. Today we're discussing 2 assignments, which is 2-sum and baby snake, which we were not able to do in week 1, so we're moving it to today. Week number 4 will be NumPy and working with data. Week 5, I'll be back with pop-up shop and breakout, which is another graphic assignment. And on week 6, Vicky will talk about images. Please note that depending on the week, the time is either 7 a.m. like right now, Pacific time, or 6 p.m. Pacific time. So do pay attention to that. And Vicky asked me to make sure that for week 5 and week 6, you know where to find the materials. So if you go to the post, which is on the Code in Place main forum, and even let me share my screen. So I think this would be easier if you are not sure where to look for the materials. Let me share my screen. I hope you can see it now. So this is the post, and in this post we have the topics week by week. And here you can see for week 5, you have a link for starter code download. And for week 6, you also have material download. So if you click those links, you will be able to access the materials needed, because they will not be available on the Code in Place website. So that's that. And now let me go back to the presentation. There is also one more person. We have sort of like a guest of honor today. I hope I will be able, give me a second, I hope I will be able to share with sound. I think there is an option here. So let me introduce you to our very special guest. Once again, thanks to Vicky. I hope you remember this guy. So here is a brief message from him to all of you.
Hi everyone, I hope you enjoyed Code in Place. Thanks for taking part in this journey to learn about programming. And as you continue your journey, there will be some things along the way that might appear more difficult, like when you get into nested structures or learning about dictionaries. And the thing you should know is that all good programmers have struggled with those concepts as well. Sometimes when you learn something new, it can be challenging, it can be hard, but you shouldn't give up. You will get it too, and it will all work out. I wish you the best in your coding journey, and keep learning.
Okay, so that was a message from Meran. I hope you saw him and you heard him fine. Just give me a sec. There we go. And as usual, at the beginning of our session, there is going to be a quiz. And this time the quiz will be the following. On the next page, you will see a slide with 2 images of the same waterfall. And you will have to write the name or the location of the waterfall, as well as the country where it's located in the Zoom chat. And the first person to do this correctly will get a $5 Amazon gift certificate from Vicky. Also, there will be an additional question, and this additional question, and who was actually the photographer who took the first photo, which is the black and white photo. And if you answer the first question correctly and the second question correctly, you will get an additional $5 for a total of 10 if you are both the first person who answers and who names the person as well. But you have to answer correctly, the first question correctly. So let's take a look at the pictures, and we'll be monitoring the chat. So here are the 2 pictures of the same waterfall. One is in black and white, the other one is in color. You need to name the name of the waterfall or the location where it's located and the country that it's in. So let's see. Okay, so Vicky, I see some answers. Which one is the first correct one in your opinion?
I think Sanjay got it right.
Yes, so we have Yosemite Park, which is the location, and the country is USA. So that's the correct answer to the first question. Does anyone know? Okay, I see RJ Taylor Jr. answering. Well, technically, the answer
Technically, that's not right, because it's not Yellowstone Park. So
exactly, and Venezuela, unfortunately, is also not the correct answer. So this is Yosemite Park, and the name is a bit different. The name is Nevada Fall, if you're looking for the name of the waterfall itself, but like I said, we accept Yosemite National Park as well. So yes, Elizabeth, you're correct. Nevada Falls is the correct name of the fall. So how do we go about this, Vicky? Because the name of the photographer.
Oh, that's okay. So no one gets the name of the photographer. So I'll just
Well,
keep my
I mean,
$5.
RJ got the name, but not the correct answer for the first one. So it is indeed Ansel Adams. That was the correct answer, but you had to name the park correctly, and it's not Yellowstone. So once again, the $5 go to the first correct answer, which was once again, I can't find. Okay, so it was Sanjay K. And Vicky, you want to give a brief overview of the location, why you chose this?
Well, why I chose it, it's actually very easy because it's one of my absolute favorite places on this earth, although I haven't been to everywhere on Earth, but this place is absolutely beautiful. So if you're not in the US, I hope one day you'll have a chance to visit this really beautiful place. And so Nevada Falls is actually part of two cascading falls. It's the upper fall, and the lower fall is shown here. That's the Vernal Falls. Most people have seen the Vernal Falls, but very few people, well, fewer people make the trek up to the Nevada Falls. And then the trailhead of these two falls actually starts at a place called Happy Isles. And so it's said that nobody can leave this place unhappy.
So if you want to be happy, this is the place to go. Almost absolutely guaranteed you'll get your happiness there. All right, so thank you, Vicky, for the quiz and for the prize. And let's talk about the plan for today. The plan for today is the following. We will do a brief reminder of how to loop over lists, because that's going to be helpful in the assignment which we're going to be doing, which is the two-sum assignment. We'll discuss several algorithms on how to solve this assignment before actually doing it in breakout rooms. After that, we'll look at one of the solutions, and then we'll spend, half of our session today, about an hour, on the baby snake problem. That one we will do together in the main room without going into breakout rooms. So that's the plan for today. Let us start with the theory behind looping over lists. So this is something that's been discussed in Code in Place, but it's always good to repeat things to make them stick in your mind. And there are actually several ways of how you can loop over lists, and we will talk about them right now. If at any point in time you have a question, I would ask you to raise your hand, and I will answer them. So the first way you could loop over a list or iterate over a list, which is the same. Let's say we have a list which is called names, and inside this list we have 4 names: Andrew, Bill, Courtney, and Donald. What would be the ways we could iterate over it? So the first one, we could iterate directly over the values. So over Andrew, Bill, Courtney, and Donald. And the syntax for that is very simple. We're going to use the for loop, and we go for value in names, colon. And instead of value, you can use whatever variable name you want. But in this specific, you could say, for instance, for name in names. But here, to highlight that it's the value that we're accessing, I'm using the value as a variable name. So for value in names, and then, for instance, if we were to print the value, we would get the following result. So in this loop, we would iterate over the strings one by one, and those strings would be printed one by one. So that's one of the ways to iterate over a list. That's the simplest, I would say, way to do it. But sometimes this way is not enough. Sometimes you want to iterate over indices. And in this case, you would do it a bit differently. You would go for instance, index. You could go for I. I is the short for index. So for index in range, remember, range is a function which returns a sequence of numbers. And in our case, we will use another function, which is len, to get the length of our list. So if we look at this, we have len names. So the length of this list is 4. And when we have range 4, we actually get a sequence starting from 0 and ending with 3. Because remember, when you do range, you do not get the last value. So we will not actually get 4, but we will have 4 indices, 0, 1, 2, 3. And that's the ones we're going to iterate over. And then inside, for instance, you could use this index to place a number before the name. So in our case, I'm using an F string, and inside this F string, I'm taking the index and adding 1. So instead of 0, 1, 2, 3, I would actually have 1, 2, 3, 4. This is one way you could do it. And then I'm printing the name, which is in this list under this index. So this is the syntax for getting a value from a specific location in the list. So if I print this, if I run this program, I would get the following output. I would have 1 dot Andrew, 2 dot Bill, 3 dot Courtney, 4 dot Donald. So I'm sort of placing numbers in front of the names. There is actually one more way how we could loop over list, which allows us to get both numbers and values at the same time. Instead of the range function, we would use the enumerate function. And I'm not sure whether this function has been discussed in Code in Place or not. I don't think so. But the way it works is the enumerate function actually returns both the number and the value. And you can save them both by writing for number comma value. So here, as you can see, I have two variables, and the actual number goes into the first variable and the value goes into the second variable. Once again, I can name them whatever I want. I can name them N and V, but for purposes of clarity, I'm actually naming them number and value. The thing that is important here is the number is not necessarily an index, because you can actually specify using the special start parameter, you can specify from which number you want to start. So here, as you can see, I'm writing start equals 1, and that's why the numbers go from 1 and not from 0. If you do not specify this, they will go from 0, so they will be equivalent to indices. But in this case, they start with 1 and they actually end with 4, so the result will be the same as in the previous example. But as you can see from the F string here, the F string is a lot simpler. So before we actually had index plus 1 and names index, which makes it a bit harder to read, but here it's just number, period, value. That's it, because I have both of these coming in at the same time from the enumerate function. So the result is the same. And to recap what I just said, if you only need values from the list inside the loop, you do not need the indices or the numbers, you just use for value in list. This is the simplest way of doing it. However, if you need both, the numeric values and whatever is stored in the list, you can either use for index in range, and here you use the length of the list as the parameter for range, or you could write for number comma value in enumerate, and the parameters are the list over which we're enumerating, and an optional parameter from which number you want to start the enumeration. In our case, it's 1, but you can place 10 here and it's going to be 10, 11, 12, 13, 14. You can leave it off and then it's going to be going to start from 0. So that's the theory that I wanted to recap with you today. If there are any questions on this specific theory, or why would you use one and not the other, or whatever questions you have, this is probably the best time to ask them. And yes, I see the question about Jupyter and data, and Vicky saying Alex doesn't do data. That's true. I don't have much experience with Jupyter Notebook and NumPy and what have you, so I'm not really qualified to talk about those subjects, but there will be a discussion on NumPy next week with Chris. So yeah, that's the plan. And I do not see any raised hands, so that leads me to believe that everyone is clear on the subject. But if not, if at any time you have a question, please feel free to raise your hand to ask it. And okay, I see a couple of questions in the chat. Guys, the reason I'm asking to raise hands because I cannot monitor the chat constantly. So right now I'm looking at it, so I caught the two questions. So the first question is, can we talk about arrays at some point? Python does not use arrays as a inbuilt data type. So arrays are something which is used in different programming languages. Python does have arrays. You can import a module which works with arrays. And the difference between arrays and lists is basically that arrays are always of the same data type. So you could have an array of integers, you can have an array of strings, but you cannot have an array that combines both integers, strings, floating points, booleans, etc. And this is the advantage of Python lists, which can actually do this. Mansi, you're saying I do not see the point of enumerate. We can access the values easily using the index. Sure, I'm not saying that you have to use enumerate, but enumerate makes it easier to get both values at the same time. It's a little bit messier when you use indices, especially if you want to do some math with those indices. But you are absolutely correct. If you do not want to use enumerate, you do not have to use enumerate. You can just use an index. That's fine. Should we always use enumerate? No, it's not like you have to use it. Like I said, if you feel like using it, you use it. If you don't, then you don't. In my opinion, sometimes it is more convenient, but sometimes an index is enough. So that's that. Alyssa, I see a raised hand. Let me know what your question is. I cannot hear you at the moment if you're saying something. Your mic is off.
Okay, here we go.
Yeah.
Can you loop through lines in a file?
In general.
Okay, thank you.
Yes, I mean you can using a for loop. You can go through lines in a file. So if you open a file for reading and then you go for line in whatever variable your file is in,
Okay.
then we'll get them line by line inside the loop.
Okay. I was working on something about that called for that, and I was kind of wondering.
Yes, a for loop works beautifully with that. So yes. Okay, any other questions, or shall we go into the two-sum problem? Okay, let's talk about the two-sum problem and what the problem actually is. So we will be asked to create a function which is called two-sum, and the function will take in two parameters. The first parameter that we're going to receive is a list of integers, and this list of integers is called nums, and we do not know in advance how many integers are in there. It could be one integer, it could be 5 integers, it could be 100 integers, it could actually be 0 integers. The second parameter is a single integer which is called target, and what we have to do is for the function to return true if any two distinct values in our list add up to target. So if you have two numbers and you add them together and you get the target number, so that means we found two numbers which give us the sum, and we should return true. Otherwise, if there are no two such distinct numbers, we have to return false. And let's take a look at some examples. So for instance, in this example, we have a list of 4 numbers and the target number is 6. And in this case, this is true because, for instance, 2 plus 4 does equal 6. So there is a pair of numbers here which add up to the target number. Another example here, the same list and the target number is 5. This should also return true because there are actually 2 options here. 1 plus 4 equals 5, but also 2 plus 3 equals 5. For us, it doesn't matter how many such pairs of numbers exist. If at least one exists, the result should be true. So here we have 2, 4, 6, and none of these 3 numbers add up to 5. If you take 2 of them, you will never get 5. So this should return false. In this one, we have 5, 7, 9, 11, and the target number is 11. And it's important that this should be false because we actually have to add together 2 numbers. If there is only one single number which is equal to the target, that is not what we're looking for. This should be false. Otherwise, there is no way for us to get 11. Another example, this is important. If you have only one value, even if that value is equal to the target, this is false because we need to have 2 values. And the final one, edge case, if you have an empty list, this should automatically be false because there are no values in there. They're not equal. There are no 2 values which are equal, for instance, 0 in our case. So these are the examples that should work when you check your program for working correctly. Will there be repeated numbers in the list? Sanjay, it's possible that there will be repeated numbers in the list. So you could have a list which has 10 numbers which are the same. So yes, the answer to that question is yes. So now, if you have any questions on the problem itself, on the assignment itself, what we should be doing, please raise your hand and I will answer them. But now I would like to do a bit of an interaction with you. Do you have any ideas on how you would approach this problem? And right now I'm talking about not specific code, but an algorithm in general. So what would you do, maybe even as a human, not as a computer, but as a human, how would you approach solving this problem? So Steve, I see your hand raised. Let's start with you.
Okay, hi. This problem got me here. Okay, yeah. This problem reminds me of a kind of a similar problem that somebody, I forget who, did in one of the events. And normally you would go through and start adding together. But what he did was similar. He started by subtracting and seeing if those numbers were in the list, a new list. And that way you don't have to keep adding. You can see the minute there's one there that adds together for the target, you've got your 2 numbers. And
okay.
I don't remember exactly how he did it, but I remember he did it like that.
Okay, yeah, this is actually an interesting algorithm. You're absolutely correct, where you go number by number and you take each number and you store it in a separate list of numbers you have already seen. And then for each future number, you see whether if you take the target number and you subtract the current number, whether the result is already stored in the list which contains, all the numbers we've previously seen. The only thing that makes this algorithm maybe a bit difficult for us at this moment is that it uses a certain data type which was not discussed in Code in Place. It's a data type which is called a set. A set is an unordered data type, an unordered collection in which each value appears only once. So basically, if you have a list of 10 identical values and you turn into a set, the set will contain only one value. And the reason why this is important is because sets can be iterated over much quicker than, for instance, lists, due to the way they are implemented behind the scenes. But I wasn't planning to discuss this specific algorithm for the simple reason that most of the people here, I would presume, do not have the knowledge to actually implement this algorithm at this time. But thank you for talking through it, because that's actually one of the better ways of solving this problem. Any other ideas on how we could approach this problem besides the one that Steve outlined right now? Once again, if you have an idea, raise your hand and let's talk through it. I mean, imagine that you are you. You're not a computer. You have, a note, like a piece of paper. On this piece of paper, you have several numbers. How would you check whether these numbers, add up to a target? Katrina, what's your idea?
Hello, can you hear me?
Hey, yes.
Hi. So I would go actually, well, first of all, it should be while length of the num list has to be greater than 1.
Okay.
And I would go with first number, the 0 indices, then 1, 0, 2, 0, 3, 0, 4.
Okay.
If nothing equal to target,
Yeah.
I would remove the 0 and start with, so the index 1 will become index 0, and then again.
Okay, so your idea is to sort of loop over the indices, go from 0, 1, 2, 3, if we have, for instance.
And add. So
4.
I would do like this. For I in range 1 to the end of to the length,
yeah,
I would do sum of num 0 in num I, and if it equals to target, I would return true.
Okay. Okay, so basically you're iterating over all the indices, and for each index that you're iterating over, you would iterate over the other indices once again, and you sort of add the first index and the second index, and if they add up to the target, you return true. Otherwise, if you go through all of them and none of them add up to the target, you return false. Did I understand your idea correctly?
I think so. I would have, start from index 0, index 0 plus 1, index 0 plus 0 plus 2, 0 plus 3, 0 plus 4.
Right.
Nothing worked.
Yeah.
I think I would pop the 0.
Okay.
So index 1 will become 0 now, and I'll do the same thing till the length of the list becomes 1.
Sure. Okay. So this is something which this is the first approach that I have. I call it the nested loop algorithm, because basically you have a loop going over indices, and inside each iteration of this loop, you are doing another loop over the remaining indices, like all the indices that follow. So this is one of the algorithms we're going to discuss. So yeah, thanks a lot for talking through that one. Any other thoughts on how? I see Andy, you're agreeing with Katrina. So I think this is the algorithm that would pop into your mind the first. It's the most logically. If you were a human, you would probably do it like this. If you had some numbers on paper, you would go, okay, so the first one plus second one, no, plus third one, no, plus fourth one, no. Okay, let's try second plus third, second plus fourth, and so on and so forth. Yes, and I see actually Dieter is mentioning in the chat a very important comment. When popping elements, you should be careful because you are actually altering the list. So you should be careful not to jump over elements. Generally, it's a bad idea to mutate a list over which you're iterating. Although I would say that from what I felt Katrina was saying is that each time she's going back to 0. So basically she's each time going after mutating the list, she's going from the first element of the remaining list until the end. So I think in this specific case, it would work. And Katrina, you're saying, I feel like it's very straightforward. And this decision is pretty straightforward, but the issue is it's not the best decision. It's not the best algorithm. So does anyone have maybe any other thoughts? Maybe someone had, a different way of doing this. Amrita, let me know
Yeah,
hey, how are you doing?
yeah, hi. Sorry. Yeah, I'm good. Sorry, I joined late, so I didn't get that it is list or array. So my idea is there is a target for some, like for example 7, and there is a list like 2, 3, 5, 7. So what
Yeah.
we can do iterating through the list from I to length, and
Yeah.
target minus I if it is
Yeah,
in list.
we already discussed this one. Yes. So that was the
Okay,
first
okay.
one. We
Okay,
discussed
okay.
looking for subtracting the current value from the target and seeing whether this value is already in the list. So yeah, that works. I actually like Catherine, you're saying just choose two random numbers from the list and add them up. And if you're lucky, then maybe you will hit at some point in time. But then the question becomes, if you never hit, will you get, infinite loop? And it will go on and on, choosing randomly, until the end of time. So, Yvonne, I see your hand. What do you have in mind?
I'm wondering, would it make it more efficient if we check the list for numbers that are larger than the target and then removing them? Because obviously adding those two numbers won't be
Okay,
the
that's an
target.
interesting idea. So
And then,
basically, you want to throw out numbers that by default will not work because, if you add anything to them, they will be larger than the target.
presumably without negative
Yeah, yeah,
integers
yeah.
in a list.
Right. This is actually important because with negatives, I'm thinking whether this could play a bad joke on you if you have, but no, it would still work. No, it would work with negative integers as well. So this is an interesting idea. I didn't think about this one. It touches upon the idea of simplifying the process by discarding immediately values which will not work. You would probably have to sort the list first and then do a cutoff. So you find the first value which is higher than target, and then remove everything, like slice off everything that goes after that value. So that's interesting. Vicky, I saw you raise your hand as well. Do you want to throw your idea in?
I don't think I would ever do it this way, but you could sort the list and then add the two numbers from the end. Um, and so you would add like the first and the last number and then move um, uh, by one position from each end towards the middle.
Okay. So basically, the idea is that if you have a sorted list, you could start from the ends of the list and add the two numbers, which is the leftmost and the rightmost number. Look at the sum, and then if that sum is larger or smaller than the target, you would either move the left side or the right side to the next number and add them again until you either find the target or the two sides meet each other, and that means that there is no such
Answer.
answer. Yes. So this is the second algorithm which I wanted to discuss today. So thank you, Vicky. I'm calling it the converging values algorithm. I named myself. It's not something you can probably look up on the internet. But this is a second algorithm we could use that's well within our knowledge base at the moment. It does not require us to possess any additional information, unlike the very first one we discussed, which uses a set. Because if it does not use a set, then it's very close to the nested loop algorithm in terms of the results that we get. But let's talk about these two. So the first one, the nested loop algorithm, let's say we have this list and our target number is 6. So basically what we're doing is we're iterating over the entire list, the values in the list. So we're going to have the variable I, which will first be 1, then 2, then 3, then 4. And actually, we do not need it to be 4 because there's nothing to add to 4. I mean, where 1 will be added to 2, 3, and 4, 2 will be plus 3 plus 4, 3 plus 4, but there is nothing to add 4 to. So we can remove 4 and actually iterate from 1 to 3. And then, for instance, let's say that I is 1. And inside this loop, we're going to iterate over all the remaining values. So after 1, we have 2, 3, 4. So that's going to be a nested loop, which will be inside the first loop. And we're going to iterate over 2, 3, and 4. And what we're going to do is, like, first we check 1 plus 2. What's it equal to? It's equal to 3. That's definitely not 6. Okay, 1 plus 3, not equal to 6. 1 plus 4, not equal to 6. So now we move to the next number in the outer loop. Now we're going to start checking 2, and the inner loop will go over all the remaining numbers. In our case, it's 3 and 4. So 2 plus 3 is 5, it's not 6. But then we reach 2 plus 4, and that is 6, and we have found the target. So that's a success. We know we found the result. So at this specific moment, much like you proposed, we return true from the function, and we do not even need to check the 3 because we have already found the result here. One result is enough. We do not need to check anymore. So does this sound like the algorithm that we've just discussed? Is this what you were talking about? Okay, so I hope the illustration sort of helps, because I know some people, are visual, and it's easier to see this as a picture as opposed to talking through this with words. So this is one algorithm. The second algorithm is the one which we called converging values that Vicky talked about, let's say we have this list, a list of 5 numbers, 1, 3, 4, 5, 9, and the value we're looking for, the target, is 8. And what we're going to do, we're going to set the indices that we start working with to the first in the index, which is 0, and the last one, which is length minus 1. So this one is L for left, this one is R for right. And first, we're going to add these two numbers, 1 and 9, and the result is obviously 10, and 10 is obviously higher than 8. So then the question becomes, if 1 plus 9 is higher than 10, what would be the next logical number to look at? We obviously need a number which is lower. And in our case, instead of 9, we can now move to 5. So we're going to move the R pointer one space to the previous value. And in this case, we're going to look at 1 and 5. 1 plus 5 is 6. And in our case, 6 is lower than the target number we're looking. So the next one we need has to be higher. And in order to get a higher sum, we now need to move the left pointer one space to the right. So now we're going to have 3 and 5. And we're going to check 3 plus 5 is equal to 8. And at this moment, we're done. We found the target number as the sum of two values. So the thing that you need to understand about this algorithm, if at any time L equals R, so they actually converge into 1, that means there is no solution. So you checked all the numbers and all the combinations, and the result that you received is, there is no solution. So in this case, you return false. And the second one thought is an important caveat. The list must be sorted in ascending order for this to work, because if the list is not sorted, this will not work. So in the examples which we actually have in the code in place assignment, for some reason, all of the lists are sorted, but that's a very dangerous assumption to make if you do not have it specified in the assignment itself. So you have to bear in mind, if you have a list which is not sorted, you have to sort it first before using this algorithm. So these are two algorithms that I wanted to discuss with you. And the question which I wanted to ask you is, in your opinion, which algorithm is better? So on one hand, we have nested loop. On the other hand, we have converging values. And the question becomes, which of these two you think is better? Does anyone have... this is early. I asked not to... okay. Can we stop the poll and then do it again? I actually wanted to talk through the logic before doing
That's
the poll.
fine. But I just don't want people to enter a billion answers in the chat.
I'm not
Because
asking anyone
then it
to
makes the chat
enter
very hard to read.
in the chat. So with voice, the reason Vicky is doing polls is because it's very difficult to read a lot of answers in the chat. It makes it more difficult to work with it. So can someone maybe answer via voice?
I think it's the second one.
Okay, why?
It needed less calculate.
Okay, the thing that is actually important before we talk about which algorithm is better, you have to make sure you understand what you mean when you say that an algorithm is better. So different people may have different ideas, you know, what better means. So a better question actually would be which algorithm is more efficient. And when we talk about efficiency, we actually talk about being efficient with something, with some resource. And when it comes to computers, there are two resources which you usually talk about. It's the speed with which the algorithm works and the amount of memory which the algorithm takes up, because memory is not infinite, and the less memory you use, the more efficient your algorithm is. But usually it's more important to talk about speed, as in the number of calculations it takes you to reach a result. Because, I mean, both of these algorithms will give you the correct result, is which one is faster. And now we can start the poll, because now when we understand what efficiency means, this is the place where it would be better to actually see answers. And Vicky, okay, I see polls, but I can't launch it again, can I?
It's already launched. Again.
I think it's stopped. It says poll ended.
I'm sorry, I closed it when I heard Alex say that he didn't want it up there. So I think I killed it. Can you launch the second one?
Yeah, hold on. I
Sorry
didn't
about
kill
that.
it, Alex.
Yeah, I know. I'm not saying you did. I'm just saying that
Wait, hold on.
we need to launch it again somehow.
Okay, so okay.
Okay, yeah. So if you don't see actually where to, okay. So let's just spend 30 seconds to see, okay, so actually I see a picture with the correct answer on it. So I don't know why you would actually include the picture of the correct answer in the quiz.
Picture with a correct answer on it?
Yes.
This picture has an answer on it?
Yes, it's color coded. But anyway, so yeah, let's, I see that still there is a variety of answers. Most of you are correctly answering, saying converging values. Some are saying nested loop. Some believe that both are equally efficient. The correct answer is indeed converging values. And the reason for this is that it takes less computational power to do the converging values algorithm than the nested loop algorithm. So it takes less actions. The reason for that is when you do a nested loop, you have you have to go through all of the values, and then for each of those values, you have to go through the values once again, which give you like a quadratic, what would be the word? My English is failing me right now, like quadratic.
It's the scaling with very long lists. So if you have 1,000, it's 1,000 times roughly
1,000
500.
times, well, yeah, you could say
Exponential.
1,000 times 500, but basically it would be 1,000 squared, close to it. While with converging values, you only need to move through values once. So basically, if you have 1,000 values, you only need to make 1,000 take 1,000 actions. While for nested loop, it could be 500,000, which is a very big difference. So this is something which is called algorithmic complexity, and we're not going to discuss it right now because it's a separate topic, which is quite difficult. It's a large topic. But the reason for this is just to make you think about the fact that some algorithms are more efficient than others, even if they give you the same result in terms of the final return value in our case. So some algorithms are going to be faster, some of them are going to be slower. And when you start working with large amounts of data in real life, it suddenly becomes very important because computers are not omnipotent. Computers can bog down quite significantly, when dealing with large amounts of data and algorithms which are not as efficient as some others. I see a couple of raised hands. So Katrina, you have a question, a comment?
Question. My question is there a function to arrange your list in the ascending, right? The correct word,
Yes.
from ascending order. Is there just a function for that?
Yes.
Or you have to write the code?
No, there is already a function which will be more efficient than if you write the code yourself, probably, because it's been worked on for a long time. The function is called sort. It's not a function, it's a method. It's a list method. So for instance, if you have a list which is called numbers, you could write numbers dot sort, open parentheses, close parentheses, and that will actually sort your list for you. And the interesting thing, even if you have to sort the list for converging values, it will still be more efficient than working with the nested loops on an unsorted list. So good question. I remember I saw a second hand. Was that a similar question? Because I don't remember who the second. Okay, yeah, RJ.
A similar or nearly identical question.
Okay. So did I answer that? All right. I would guess so. Okay. So now is the time for us to actually go into breakout rooms and code this problem. We will have. Let me see. I remember seeing a message with numbers and I already lost it. Okay. So we will have 12 breakout rooms. So we will have about 4 to 5 people per room. You will have 15 minutes to try and code this problem. Now that you have a couple of algorithms, you're free to choose whatever algorithm you want. And in 15 minutes, we will come back and actually go through this problem together and solve it together. So I think we're ready to break people up into breakout rooms. Is ended. I know. I would ask everyone to turn their mics off so we don't hear you in the main room. And I know that some teams were able to finish in the given time. Some teams were close, depending probably on what algorithm you decided to implement. So now let's actually talk about the implementation, because I know that not everyone was able to finish. I see the comment that fingers went on strike. Sometimes that happens. So let me open the problem on my screen. And just give me a second. Yeah, I just muted everyone. So let me share my screen once again. And here is this problem on my, no, not 42, 24. Let's go 24. There we go. So I would actually try doing the second implementation, which is about the converging values. We could probably try doing both, but we're running out of time a bit. That seems to be the usual thing with me. I talk too much, as Vicky says. So let's first try the second version. And once again, I would ask you to raise your hand if you wish to help me out here with the solution. So if we do the converging values, what is the first thing we need to do in this function? Could someone help me out here, raise a hand? Let's go, Nancy.
Yeah, so first thing we need to do is like set two variables like left and right and assign them indices of
Okay,
list.
so what would be the indices for left and right?
Left would be 0 and right will be length of list minus 1.
Okay, length of the list minus 1, why minus 1? This is important because if you take the length of the list, you will get one index beyond the list.
Yes.
So this is important.
Yes.
You have given minus 1. Okay, good. Thank you for this. So can someone else help me out with the next step? We have our indices, the leftmost one, the rightmost one. So what do we need to do next in this? Lori, shoot.
I thought you have to sort it.
This is true. This is true because we cannot be certain that it's sorted. We do have to sort it. How would we do that?
And I thought you had to do it before you did the left-right thing, but I don't know.
It would not change left and right because it would not change the length. The length would remain the same, so the left and the right would remain the same. So we could do both before or after. But I mean, logically, I would agree with you. It's better to do before. So what would the code?
So I think you do nums, the name of the list, dot sort with parentheses.
With the parentheses. So this is one thing that I want to ask you to pay attention here, because there are actually two different ways to get a sorted list. And the first one is this. And what's important to understand is the original list is, let's say, mutated or changed in place. So you are actually changing the original data. But some of you thought that it would be better to create a new list. And they tried doing something like this: new list equals nums sort. But the problem with this is incorrect, as the sort method doesn't return anything. It changes the list in place, but it does not return anything. So it actually returns none. You would not get a new list. If you really wanted a new list, you would have to use the sorted function. It's a function which takes in any collection as a parameter and returns the sorted list created from that collection. So in this case, this is a new version, a new sorted version of the list. So we're going to use this one. We're not going to use these two. These are incorrect. Okay, so we sorted our list. We have a new one. So to be consistent, we could here use new list, although the length would be the same. What would be the next thing we would need to do? Nancy, you're up again.
Yeah, so I was thinking that we can use a while loop because we don't know how many steps we will need. And
exactly.
We will, yeah.
So what would be the condition for the while loop?
While left is less than right, because it can't be equal to and it can't be greater than.
Sure. You could do while left is less than right. You could do while left is not equal to right. Doesn't matter. Gives you the same result. So let's stick with your proposal. So we're going to do this until left actually becomes equal to right. The second way you could do this is actually right while not left equals right, because that's the logical thing, right? But let's stick with your, because your is good as well. Okay, so now inside this loop, can someone else throw in an idea? What would we do inside this loop? How would we work with this? Flora, I'm all ears.
I try. I didn't solve it this way, so I'm trying. Sorry if I am wrong, but I will go for if.
No problem.
I need a total or something here.
Sure.
Yeah. If a total.
You could do the total before, or you could actually write the total in the condition. It's your choice. It's your call.
Then I will start putting it. I think I would go this way, and the total is equal to target. Then I will return true. Would that mean something? It's like this is how it sounds right in my head, but
it is correct. But then you would actually get the total. How would you get the total? Because we don't have the total yet.
Yeah.
Can someone help us out here? How do we get the total?
Left plus right.
Left, yes, right.
But left plus right, those are indices. Indices are not the values.
You would put new list,
right.
New list,
and then those parentheses, and as an index will be left.
Yeah.
Okay, so you write left. Yeah.
And then you do the same for right.
Yeah.
Mm-hmm.
So this would give you the total, and now you can work with the total in the condition. So the first one, if total is equal to target, return true. What are the other options we're looking at?
Can I ask you something?
Sure.
At this, because we had the discussion last week with the elif and the if.
Sure, you can use both here.
Okay. I still have some issue understanding why both are working and why is not elif the best solution in this case.
Logically, it would be correct to use elif. The reason we could use if here, because if this is true, we will return the value and the function will end. So this will mean the end of the function. We will never reach the next line.
Okay,
so,
because okay.
But let's do elif. Elif is absolutely fine.
Yeah.
So elif.
Is it still me talking? I can continue.
Sure.
If total is less than target.
Okay.
Give me the time because I'm doing this. So while we talk. So left is plus equals to 1.
Okay, so if the total is too small, then we need to move the left one to increase the next number. So left plus equals 1 is good. Okay.
And we need an else at this point.
Else, otherwise, because we have equality, we have less than. So now we only more than is remaining. In this case, what do we do?
Right, has to be less than 1. Less or equal, minus equal 1.
Yeah. So that's what we have to do. We have to do minus equals 1 to move the right one towards the center. Yeah. Okay, so I think we're good with the cycle. There is one more thing that we need to write here. Can anyone else help out? What's still missing? Mansi, what else do we need?
Yeah, the condition where the elements are like the list is empty or have one element only. That condition. Also, you have to subtract -1 from length in the right.
We are subtracting 1 here, but you are correct.
Not there. Yeah. When we initialize the variable, left, right is equals to 0.
Okay, I deleted this by mistake. Okay, yeah, we had -1, but then I deleted it. Thank you for noticing that.
And after that, we can add the condition Like if len new list is less than 2, then return false.
You could actually do it with 1 because it would work with, or you could do it with 0 only because it would work with 1. With 1, left will be equal to right, so it will immediately terminate the loop. But with 0, we will get an error here in this specific one. So it's a good idea to say if the length of nums is 0, you would immediately return false. So this is an edge case which you have to bear in mind.
You're missing to return false.
There we go. Where do I need to place it?
At the end of the while loop, like where the while return false.
At the end of the while loop or after?
No. While loop ends without fitting true. Okay, I'm sorry.
Okay, no problem. Sorry? Okay. So let's run this. And you see we have true, false for the 4 examples here. But let's add 2 more to check for edge cases. Let's check an empty list because this is important. So obviously this is also expected to be false. Let's see if that's the case. And we do get false. And let's get check one which has 1 value, and this value is actually equal to the target. So for instance 20, and we're actually looking for 20. And this one is also correctly identified as false. So this is one of the ways that this assignment can be done. And we figured out that this one is actually more efficient than the nested loops one. And we could have done nested loops, but since we're running out of time, we're going to stop here with TwoSum and go to the next assignment, which is baby.
Alexander,
yeah.
I have a quick question. What happens if you don't put that return false where the indentation is with the while loop? What happens?
If you put it here?
Yeah.
It will actually return false after the first check. So if you run, you will see that you actually get a bunch of falses, 1 true, and actually 2 nones, because it returns false after the first iteration of the loop. So we actually have to return it after all the iterations are done, and left is actually equal to right. But that's a good question. That's a good question to consider.
Thank you.
All right, so let me stop sharing this and go back to my presentation, and just give me 10 seconds to let my cat out because it's going crazy at the door. I wouldn't be surprised if the cat starts, clawing back in 5 seconds, because that's what they do. Okay, let me share the presentation. There we go. So baby snake problem. The baby snake problem is a graphic assignment in which we're basically writing the snake game, with the only difference is that our snake is always 1 pixel and it doesn't grow when the snake actually eats an apple, a fruit, or whatever it eats. So this is a simplified version of the snake problem, but still it's an interesting assignment. And it's actually split into a number of sub-steps. So what we're going to have to do is set up the game world, then animate the snake, then actually handle controls for the snake, detect collisions with walls, hitting, sort of eating the goal, the apple, the fruit, whatever it is, and moving it to another spot, and several optional ones, which I'm not sure we'll be able to do today, which is actually increasing the speed after each goal, keeping track of points, and adding obstacles to the board after, a goal is reached. So these are the ones we're going to be looking at, and that's it for the presentation. We're actually going to jump into coding right away. So let me go back to the code in place IDE. Steve, I see you're saying that it's too bad we didn't really cover the set type. Maybe later, in one of the later sessions when we actually discuss the set, we could come back to this problem and solve it with the set, but for now, I'm certain it would leave a lot of people confused, so I decided not to go into it.
Alexander.
I also see yeah.
Sorry. I didn't mean you. I just meant in code in place.
Oh, okay,
I didn't
sure.
mean I didn't mean code in place.
No problem, no problem. And Irene, I see you saying that nested loop method seems more readable and intuitive to me. And that's true, because that's the way you would probably think of it the first time you come to this problem. And like Dieter is writing, that is often the case. But at a certain point in time, you have to go from something which is intuitive looking to something that actually works better. And that's probably a hallmark of a good programmer, a person who is able to think in terms of complexity and find solutions that are maybe less intuitive, but more efficient. So let me share once again my browser. So we're done with this one. Let me increase the font size once again, 24. There we go. Okay, so Snake. The first thing that we're going to do, the first milestone, is set up the world. And the world will already have a canvas which is 400 by 400 pixels in size. And the first thing we need to do is to actually place the snake, and we're placing it, at the upper left corner of the game world, and place a goal somewhere. In our case, it says it's reasonable configuration where the goal is at 360, 360. We could place it somewhere else, but that's for us to decide. So the first thing we need to do here, and I am going to do this using sub-functions. So the first thing we want to do is place the snake and place the goal. For now, at a very specific point on the game board. So my first question to you, do you remember what we need to do? So basically, there are two things which we need to do here. We actually need to draw those objects on the canvas. That's one. But the second thing we need to do, we need to save those objects in variables so that we can actually work with those objects later. For instance, if we need to move the snake or we need to change the location of the goal, we should have a variable where those objects are saved. So right now in the main function, we have only one line. We actually have the canvas, so you can see it on the screen, 400 by 400. Also, we have a constant here, which gives us the size of the pixel. So in our case, the game board is actually 20 by 20 because we have 20 pixels, which are 20 blocks, which are 20 pixels wide each and 20 pixels high. So we could actually spend some time drawing the grid on the screen to make it obvious what the game world looks like. Maybe even let me do this quickly. I want to do a sub-function which is called draw grid on a canvas. I'm going to do this myself so it makes it easier for us to see what the game world looks like. So in order to draw this grid on a canvas, which is passed as the parameter, we would need to draw some vertical and horizontal lines to split the world into small chunks. So let me do a for loop. I'm going to say like for C is coordinate, for coordinate, like the first coordinate that I'm interested in is size. So we're going to go in range from size until the canvas width. Let's say we could also use canvas height because they are the same, but in our case, let it be canvas with step size. I'm going to draw two lines. So the first line I'm going to do is canvas create line, and I'm going to draw it from the left side of the screen. So that's an X of 0, and the Y will be C to canvas width C. So if I run this, I will get, let me change the color to gray, maybe, so it's not as So you see I have horizontal lines, I'm drawing them in this loop, and you can see now where the blocks are on the canvas. And I can actually do the second one to create the vertical lines. C0, C canvas height. Let it also be gray. And if I do this, you will see now I have the canvas split into blocks. So this is basically 1 pixel of the of our game board. And we can actually change the parameters. We can change the constant. Let's say we want size 10. If I run it now, you will see now I have a board which has pixels of size 10. I could do size, I don't know, 50. That would be a very small board, but still it would work. But in our case, let's go back to 20. This is just I'm just visualizing this to make it easier for us to understand where the snake and the goals are going to be set up on our game board. This is not something which is supposed to be done. So now, after we've done this for ourselves, let's draw the snake and the first goal. So how do we, can someone help me out? How do we draw the snake? Raise your hand if you remember what would be. Steve, is that a raised hand? That looks like a wave, but if that's a raised hand, then help me out.
It was an active raised hand.
Okay, good.
You have to set a start X and a start no, a left X and a top Y. There we go.
Okay, let's do that. So we're going to have left X and top Y for the snake.
Right, for the snake.
Okay. Do you mind if we actually call them snake X and snake Y to differentiate from the goal?
Yep, okay, snake X, all right.
Okay, what would be the values initially?
0 for X.
Yeah.
And
if it's the top left corner.
Yeah, it's where we're supposed to start. And oh my God, I'm crazy. Size.
No, it's actually also supposed to be 0.
No, 0. It's the top. I'm sorry.
Yeah,
I was looking the other side already.
No
top
problem.
Is 0. So,
no
yeah,
problem.
I'm already at bottom.
These are the coordinates of the top left corner of the snake. We have them now. Good. And while we're at coordinates for the snake, how about we also set the coordinates for the goal as well? Might as well do that. So according to the assignment, those are supposed to be 360 at the beginning. So then we'll change them later. So let's say goal X, goal Y are equal 360, 360. So there we go. We now have the coordinates. So the thing that we now need to do is just put them on the screen. So I would actually do 2 separate subfunctions. One would be draw snake. I would pass in canvas, obviously. What else do I need to pass into this function? And then I would do draw goal with the same logic. So any ideas? What do I need to pass into these functions to actually draw the snake and draw the goal?
Size and coordinates.
I do not need to pass in size because size is a constant which is available from anywhere inside the program. But the coordinates, you are absolutely correct. Here we need to pass snake X and snake Y. And in this one, we have to pass goal X and goal Y. The interesting thing is I could actually do this with one function, because what I'm doing is I'm actually drawing rectangles of different colors. So why create 2 functions where I could create one? I could just say draw square and add a color here. So I will pass some color. So the first one will be draw square for the goal. The second one be draw square. The first one for the snake, the second one for the goal. And the first color is going to be supposedly blue. And the second one, I think we're told that it's red. It looks more like pink, but let's stick with red for now. So if we want to, write this function, we're going to have canvas X and Y. I will call these parameters simply x and y, because in some case they will be the snake, in some case they will be the goal. For us, it doesn't matter. It's just an x and y coordinate, and then we're going to have the color in which we're going to draw that square. So can someone help me out here? How do I actually draw this square? Mansi, let's go.
Yeah, so first what I'm going to do is add the keyword return, because what I am doing, that has to be returned.
Okay, that's a good one.
Yeah.
So the question is, what are we returning? Okay, we can immediately return. And this is a good idea because here we actually need to save this. Let's save this into a couple of variables. This one is going to be snake, and this one is going to be goal.
Yeah, so I'm going to use canvas dot create rectangle. Yeah, underscore and create rectangle, and inside parentheses I'm going to pass first the left x, that is the x that we got inside our function, then the y, then y, then comma x plus size, then comma y plus size.
Yes.
Then the color.
Okay. This is absolutely correct. So just to make sure we all understand what's going on here, we are drawing a rectangle using the create rectangle function. It accepts 4 coordinates, the top left coordinate and the bottom right coordinate, or the other way around, right bottom, and here it's left top. So what we're doing, we know that x, y are actually the top left, and in order to get the bottom right, we need to add size. So if the top left is 0, 0, obviously the bottom left is 20, 20, because we have size 20. If we change size to 50, for instance, it's going to be a 50 by 50 rectangle. So it works, it should work in this case. So let's see whether it actually gets the job done. And as you can see, we're on the program. We have the snake in the top left corner of our game board, and we have the goal somewhere at the bottom. So we are actually done with milestone 1. We have this drawn. The grid is not necessary, but we can turn on the grid at any time we want. Are there any questions at this? Salmon. Okay, Mansi, I like salmon. Let's try salmon instead of red. It's like, I remember if you watched the TV show Friends, there was one episode where they were discussing Ross's shirt, whether it was pink, or he was saying it's not pink, it's salmon. So yeah, it's not pink, obviously. Okay, there we go. We have a very nice color. If there are any questions on this part, the first milestone, please let me know. Please raise a hand. I'll answer them before we go into the second milestone. I will talk through the second milestone right now, but if you have any questions, please let me know. So the second thing we need to do is actually animate the snake. It should just go, you know, from left to right without stopping and disappear, you know, somewhere on the right. It's Peach. Okay, Peach is a good one as well, Steve. So we need to add some animation. And my question to you now is, what do we need to do in order to animate our snake? Because in a program, in a game like this, you basically have 2 parts. You have the setup part, and we have mostly, you know, our game set up here. But after that, the game actually begins, and that's the second part. That's the, you know, that's the game loop. So my question would be, how do we set up this game loop that it plays over and over and over and over until a certain condition for the game's end is reached? Mansi, shoot, your hand is up first.
Yeah, so what we are going to do is use a while loop that will be true. Condition will be true. And
okay.
Inside that, yes.
Okay.
Inside that.
It's possible to use a while true loop, because that's an infinite loop, and then inside you would have to have a specific condition which would break out of that loop. But I generally dislike infinite loops, because when you see an infinite loop in someone else's code, you have no idea what is the condition for that loop to terminate, especially if you have a very long program, and you actually have to look through the entire program to find that breakpoint that we just talked about. So let's think about it. What is actually the condition for the game to end? What are the conditions?
Like snake Y is less than like canvas width, because
But I
we are
mean,
moving.
generally, if we don't go into numbers, what are the general, conditions? If you would speak human language, you would say the game is over when what happens?
It's over if it touches any of the boundaries of canvas, like any boundary. If the snake touches, yes.
So basically, if the snake suffers a collision, right?
Yes, yes.
Okay. So we could actually include a variable which would say something like snake collision is initially false. And then we would say, why not snake collision? The game continues going. So until we collide, the game will work. And this way, upon reading this line, I immediately understand what the end condition is. So I don't have to scroll through the entire program and look for the break statement. So do you understand my logic for not using while?
Yes, I do understand.
Okay, great. So yeah, we do need obviously a while loop, because that's where the game loop is going to happen, and inside the while loop we need the snake to move.
Yes,
and
canvas dot move. Yes.
How do we do it? How do we do this?
Canvas dot move, because I'm moving it constantly.
Okay, so canvas move. What's the syntax?
Object the snake, and like how much I want to move them, like size, size.
But are we moving?
No, sorry. Yes, we are moving horizontally, so only one, like size, 0, because we are
size, 0. So this would actually move our snake by size to the right and by 0 down. So this will give us horizontal movement. And if we run the program right now, we will not even see the snake because it's going off the screen very quickly. So can someone else help me out? What do we need to add here for this program to run slower so that we would actually see the snake move on the screen?
Yeah, right after the line of canvas.move, we need to put time.sleep, and yeah, we have a delay defined, and
yes. Okay, yes, thank you, Katrina. So the reason why we're doing this is we need for there to be a delay before the next frame is drawn, because otherwise the computer is too fast. We don't even see how the snake moves on the screen. So now, each time we move the snake, there is a small delay. This delay is 0.1 second, so 100 milliseconds. And after that 100 milliseconds, the snake moves again, and so until the end of time, because we do not have a condition installed where snake collision becomes true. So now, if we launch our program, we will actually see the snake moving, and we can pat ourselves on the back for solving milestone number 2. I see a couple of comments in the chat, so let me address them. Dimitrios, you're saying snake eats itself. In this particular one, I see Alyssa answering you. It's impossible because the snake is not growing, so it will not be able to eat itself in baby snake. Furry baby, thanks for asking Blossom about my cat. Cat is doing a lot better, but let's leave it at that, just simply to save some time. It's definitely alive. Vicky, it's definitely alive. Okay, so let's take a look at the next one. The next one is milestone number 3, handle key press. And actually here we are given some code which I'm just going to copy and paste. So after we move the snake, well, no, actually I'm going to implement this before I move the snake. So this will give us immediate response to our key press, because otherwise, if you put it here, if you put the key presses here, then you will have a delay of 100 milliseconds before you get a reaction from the snake. So first we're going to read the keys, and only then we're going to move. And let me move these correctly. So now we're going to use a function which is called getLastKeyPress. And each time this method is run, it's a canvas method, it either returns none if no keys were pressed, or it gives you a string representing the last key on the keyboard which was pressed. In our case, we need only 4 keys, and these keys are called arrow left, arrow right, arrow up, or arrow down. And here at the moment, we're just going to get some text in the terminal. So if I run again and I press up, it says up arrow pressed here in the terminal. If I press down, left, or right, I need to do it in the canvas. It just types out the direction, but we need to actually change the direction that the snake is moving. So let me delete this, and I would like a discussion with someone how we're going to do this. We need to somehow change the direction of the snake, and at the moment we don't even have anything resembling a direction. So any ideas of what the reaction should be for certain keys being pressed?
Yeah. We need to, when we do canvas.move and we have size in 0, we should have 2 more variables, change in X and change in Y.
So you mean instead of these?
Instead of this, but we need to put them up before, and initially it will be change X will be size, change X and change Y, initially it will be that. Now
So you're saying that change X initially would be size, right?
And that one, yes, it starts moving, and 0, yeah.
And 0.
But now let's say if the arrow pressed down, so we will be going, so Y will be change, Y will change. It will be change X stays the same, but Y will be size plus.
But when you're saying that change X stays the same,
whatever it was at the moment, whatever it was.
For instance, let's say we're moving to the left and then you press down. Does change X?
No, that's right. Change X will be 0, then and change Y will be size.
Okay, yes. So
yeah, because we're moving on one axis.
On one axis, exactly. So to make sure everyone understands, these 2 variables actually define the speed. Do you mind if I call it speed X and speed Y?
You can call it whatever you want.
I know, but I want to sort of, be on the same, have an agreement with you, because the word change, I don't think it, in terms of the name of the variable, reflects the idea. You sort of go like change, what's change? I would actually use speed, because this means how far the snake would move in a certain direction each time we iterate in our while loop. So this is basically speed per 100 milliseconds in this case. So when you're saying here, for instance, speed X and speed Y, when we're going down, our X suddenly becomes 0 and our Y becomes size, because when we're going down, we are increasing Y by size each time it moves. Steve, I see your hand raised. Did you want to add something or ask a question?
Just a quick question, because this is where I got really, really confused.
Sure.
In the assignment description, the last thing in milestone, what are we on? Milestone 3 is, we strongly encourage you to keep a variable which stores the current direction of travel. And that really confused me, because I didn't know how to incorporate that into the...
Okay. So I'm not sure why they strongly encourage this. This is certainly one way of doing it. What we could do, instead of having 2 variables which are called speed X and speed Y, as an alternative, we could have written something like this. direction equals, or maybe even snake, well, there is nothing else with direction, so let's stick to direction. And then, for instance, you could have a list, which would be size 0. This is the same, simply keeping both variables for the direction in one variable, in one list. And you know that this is X, this is Y. I mean, for all we care, we could have done a dictionary going like X, X size, and Y, sorry, I have an international keyboard, and Y0, and then you could have changed the keys in a dictionary, because this is like more clear what they mean. But this one is the same, basically. We just have two variables. So it's a matter of taste, and I don't think we have to, like, I would not strongly encourage you to have one variable, but for some reason the CIP people decided to do that. So let's stick with the one we have right now. We figured out the down arrow, and actually if we run the program right now, we would actually be able to, would we? No. Change X, oh, okay, yeah, I forgot that it's speed now. Speed X, speed Y. So now it's going down, and we cannot move it any other way, so we need to write the for others. Can someone help me out with other three? So let's go with arrow left. When we have arrow left, what would the speed X and speed Y be?
Well, you would just pick the different combinations, right? If you're moving left or right, you would change your speed X by plus minus in the direction that is moving.
Yeah.
And then if you are moving up and down, you're varying the Y. If you're going down, I believe that would be positive. If you're going up, that would be negative.
Exactly.
So
So
you
for
could
left.
code those four directions.
So for left, what would the directions be? What would the
I
value?
believe positive is going towards the right. So if you're going left, it would be negative.
Okay, so give me the two values for left.
Sorry, it wasn't for left. And so Y would be 0, I believe, right?
Y would be 0. What would be X?
X, would that be negative speed X?
It would not be negative speed X.
Size.
Yes, it would be
Size.
negative size. Exactly. All right. So for right, using the same logic, you would have positive size and 0. You could actually put a plus. That would work as well, but no need. And so let's do the final one. If we have arrow up, what would the values be?
Arrow up, that would be positive. No, wait. Arrow up would be negative size for speed Y.
For speed Y, so 0 negative size. And if we try it right now, if I launch this, we are actually able to control the snake in all 4 of the cardinal directions. It would actually go off board, and then it would be able to return. So we don't see it's going somewhere negative, but then it actually returns back. So that sort of works. And I think we are done with milestone 3.
So
now,
Alex, can I ask you a question?
Sure.
For your canvas moves, okay, it's taking 3 parameters. And so what is the first parameter again?
It's the object that you're actually moving.
And then why is that object speed X?
No, the first one is snake.
Right, but when you're controlling your keys, you have speed X, speed Y, and then you have size. So I'm not sure.
So remember that there are 2 methods. The first one is called move. The second one is called, if I believe correctly, move to. So
Okay,
move.
you're doing the relative position,
Yes.
correct?
Yes.
Okay,
This is the
understood.
relative
Okay.
one.
Okay.
We could have done this using the absolute.
Yes, I think the absolute is a little more straightforward to see and to think about, but yeah, okay, I get it. So
Yeah, with absolute, you would actually have to each time to check the current coordinate of the snake and then add or subtract from it or what have you, but that's also a perfectly valid one. I just stuck to whatever was proposed, so I don't mind it either way. Okay, so now we need to detect collisions, and in our case, detecting collisions is actually going out of bounds. We are given a hint here that that's exactly what we're talking about right now. We could actually at any time get the coordinates of the snake of any object on the screen, on the canvas, and then obviously we need to do something with those coordinates. So I see a question, Irene, you're asking which way is more efficient. I think in terms of efficiency, they're about the same. So the amount
between move and move to?
And move to, yes. Yeah. I believe there is no difference in terms of algorithmic complexity between these two. So we're fine with both. It's a matter of personal preference.
Gotcha.
Can someone help me out with collisions? If we need to detect collisions, how do we actually do this?
We set up we have canvases, we know the canvas's coordinates, so we can get the canvas left X. It should be within the bounds, which are the canvas, width for the X, and bigger than 0, smaller the canvas width.
Okay, so the first thing, we need to do is actually get the coordinates of the snake. So let's take these two after the snake moves. We can get X and Y, or we can make it more like it would be snake X, snake Y, and we get these coordinates using canvas. Just give me a second. So canvas get left X of snake, and canvas get top Y of snake. So now we have the current coordinates of the snake. What do we do? You were talking about right now the boundaries. How do we actually check those boundaries, Katrina?
So the left X cannot be smaller than 0 and bigger than canvas width, and the Y.
So in terms of code, how would I write this?
Okay, we have the snake collision full setup. Okay, if snake X is smaller than 0, or if snake X is bigger than canvas width, right? Canvas width, or height, no, width. X is width.
Or X is width, yeah.
And now we also have to put or for if snake Y is smaller than 0, or snake Y is bigger than canvas height, then we'll set snake collision to true.
Exactly, and that's that. So that's the way we're going to break out of the while loop. But there is one thing here that bothers me a bit. I see Lori raising a hand. Lori, do you have any idea what we could maybe change here a bit?
Yeah, I thought maybe you need to subtract size
from
where you have if X is greater than snake X greater than canvas width minus size.
Mm-hmm.
And then for the snake
height.
Yeah, same with. That's all.
Okay. This is a good comment, Katrina. Do you understand why we need to?
Yes, absolutely, because the top corner will still be on the canvas, and the bottom already gone.
Yeah. So you can hug the right part or the bottom part, be outside the canvas and still not crash. In this case, it's not going to happen. So this sounds like a good bunch of conditions. So let's try running this. So here is my snake, everything's working smoothly, and now boom, the program ends. We can actually add something at the end so that we see that it's the end of the program. At the end of def main, let's say print game over. So the left one, boom, game over in the terminal. The top one, game over. The right one, game over. Let's check the bottom one. And there we go. It disappears from the screen and we get game over. So we are done with milestone 4. We are now successfully detecting collisions. And I'm looking at the time, and I know that we have, like, our 2 hours is up, but I would propose to spend, 10 minutes more and finish the final milestone, because I think we're almost there, and I don't think moving the goal is going to take that much time. So let's do the final one. At the moment, we have a goal. Oh, by the way, hold on one second. I think we're not checking a collision with the goal for the moment, because that's something else we need to do. So these are for collisions with the wall, but we also need to check whether the snake actually collides with our goal. And let me just try this myself, because we have snake X, we have snake Y. I would do if snake X equals, and probably do this separately. Let's get goal X, goal Y equals this for goal, equals this for goal. So if snake X equals goal X and snake Y equals goal Y, something is supposed to happen. For now, let's just, let's say we hit the goal and see whether that works. So we run our snakes. Sorry, I need to move this a bit. Don't run away. One more time. So if I go here, in the terminal we hit the goal. We can do this over and over again, because right now we don't have any functionality of removing the goal and doing the next one, but at least it's working. So now moving the goal and maybe actually setting up the first goal as well, I would actually do a separate function, something like get random coordinates. And we would use it here, and then we would use it every time we hit the goal. So this would also be, we would need to move them there. So let's also say goal X, goal Y. It would be the same, get random coordinates. And then we would need to move the goal to those new coordinates like we did before. So it's going to be canvas move goal, goal X, goal Y. So now the question becomes, we need to define this function. How do we get a couple of random coordinates? So let's write it somewhere separately. Get random coordinates, and we can actually use it later to generate obstacles, because they also use random coordinates, so that would work. So how do we go about this? How do we get a set of new random coordinates? Can have someone help me out here? Lori.
Oh, actually, I was just thinking, should it be move 2 for the new goal instead of move?
You are absolutely correct. I could say that I did this on purpose to check how attentive you were, but no, I messed this one up. Let me find it quickly. We need to do move 2 here. You are absolutely right. This is the place where you need to use move 2. I saw another hand. Who wants to help me out with the random coordinates? Anyone?
Well, we can do random integer.
Katrina, but I got Flora's hand.
Sorry.
Flora, shoot.
It's very fun. I wanted to say the same thing. We need a couple of random randit.
Okay, random randit, right.
One for X and one for Y. Goal. I suppose we call it goal. Now I'm a bit confused with how we named.
We can actually call it. We can call it here any way we want because we are then saving them into these variables. But inside the function, we can call them whatever we want. We can call them blah blah and then return blah.
But I use GX and GY in my code, so if it makes any sense for you, I don't want to overwrite, but I don't think we use them anywhere.
We can use like simply X and simply Y.
Yeah, okay, but anyhow, one would be a random int.
Right.
Okay, I would be on a 0, an X. Then we will have parentheses, canvas width minus size.
Canvas width minus size.
And then, oh my gosh, I am so bad with the English. I will put that in the
chat.
In the chat, a double.
Okay, so that's right. That's integer division.
Yeah, that one, integer division size. And then I close my parentheses, and then it goes multiplied by size.
Why would you need to close the parentheses here? The parentheses are closed here for subtraction.
Because I'm probably meant to maths, but I use it a multiplication, and in my imaginary idea of I have to separate it from the rest. But probably it's me that
you could do it. I mean, you did it like this, correct?
Yes, because I want to separate the multiplication, but I'm probably wrong.
You're not wrong. You could do it to make it clear what the order of operations is, so that's absolutely fine. It's not wrong. But yeah, the thing is that these mathematical division and multiplication have the same priority, so they go from left to right. So in our case, we don't need extra parentheses here. This is important. We need the parentheses here because subtraction is obviously lower in priority than division and multiplication. Can you explain to those who maybe are not sure what this is? Why do you need to do this? Why do you need to divide by size and then multiply by size? Isn't that like useless? You're doing like back and forth. It's like plus minus, divide, multiply. What's the reason for this?
That's because it's a casual position and I need to multiply by the size.
But I mean, what would happen if we actually delete this? If we don't have this, what would happen if we go like this?
Your grid is a good illustration of why.
Yes, that's one of the reasons I drew the grid. So let's try it like this. I'm going to where is my line 16? What's the problem with line 16? Okay, yeah, I forgot to return the result, obviously. We need to do this with y as well. So y, and here it's going to be height. And then we need to return x and y. So if I do this right now, you will see that the goal is actually off the grid. And that's a no-no. So because I will never now hit the goal with my snake because the coordinates are never going to be exactly those because it's not on the grid. So anytime I run this, it's probably going to be off the grid. 1 in 400 chance that it will actually be on the grid, but that's a very small chance. So we somehow need to make sure that this goal is on the grid using the random function. So the reason why you first delete, like do integer division and then multiply, to make sure that your numbers come in 20s. So you could only get a random number which is like 20 or 40 or 60 or 80. What's that called? Like multiples of 20. Is that what it's called in English? So this way you make sure that any of your numbers generated randomly is actually going to be a multiple of 20. Let's look at an example. For instance, let's say that you randomly got the number 55. 55 is not a multiple of 20, but if you divide 55 by 20, you would actually get, what would it be? It would be 2 and 2.75. But then, because it's integer division, it would actually go down to 2. And then if you multiply 2 by 20, you would get 40. So instead of 55, you get 40. If you had, I don't know, 105, 105 divided by 20 would be like 5 and a fourth. That would be, with integer division lowered to 5, multiplied by 20, you would get 100. So each number that you get after this division and multiplication will give you a multiple of 20. So this way you're always, well, no, not in this case for some reason. Give me a second. Why is it still giving us these weird coordinates? For some reason it's not helping right now. Divided by 20, multiplied by 20. No, wait. The first one, how we're getting, no, still it's get random coordinates. Go X, go Y. Sorry, no, I understand. I understand what my mistake is and why you need to close the parentheses. So it was actually, you were correct, and I'm just doing brain farts. This is the correct way of doing it, because we first need to randomly generate a number from 0 to whatever, and only then divide it by 20, multiplied by 20. Because otherwise we're just getting coordinates in this quadrant, which is not what we wanted. So now, as you can see, it fits on the grid perfectly, and I can eat it. Canvas object has no attribute move to. What are you talking about? Is it called differently? Is it move to? Is it like this, move to? I don't remember.
You wrote 2 with capital letters.
Yeah, okay, that's my mistake. So now, as you can see, we can actually eat the goals, and they are appearing in new places, and we are, I think, done with milestone 5. So this is it for the main part of Baby Snake. Obviously, there are several extensions that we're not going to do right now simply because we ran out of time and we're like 13 minutes over. But to give you some idea, if you want to get faster each time the player touches the goal, the thing that you need to change is this speed. So you would decrease the delay in order for each next iteration to go faster and faster. You would never change the constant because it's a constant. You would actually need to define a separate variable for the current delay inside main, and then change this current delay. I usually multiply it by 0.95, which is like subtracting 5%. So each time you hit the goal, the speed increases by 5%, then 5% more, 5% more, and so until it's too fast. Keeping track of points is very simple. Each time you go over goal, you have a variable points, you add 1 to that variable, and you can print it on screen using the create text or whatever it's called, and say like score points, and it would increase each time you hit the goal. And the last one is the most interesting one, is adding obstacles. Because adding obstacles would work the following way. You would, each time that this condition is met, so you got the goal, besides moving the goal, you would actually create a new obstacle object and add it to a list of obstacle objects. So initially you would have an empty list, and then each time you would append a new obstacle to that list, you would draw it on the screen. And then you would have to check, because right now we're only checking for walls and the goal, you would also have to check for collisions with the obstacles. You would have to loop or iterate over your list of obstacles and check whether the current coordinate of the snake is equal to the coordinate of this or that obstacle. And if it's equal to any one of the obstacles in the list, you would also set snake collision to true, and that would end the game. So you could try doing this yourself, and if it's not working for whatever reason, you can post your question on the main forum. And don't forget to add LACIP so that we see the question. Let me quickly see any other questions which you have. Yeah, okay, this is good. Can you, Leah, you're asking, can you use a step in the random function? Unfortunately not. Random does not have a step function. Otherwise, that would have been nice. We can create a list of numbers in multiples of 20 and then use the random choice function. We could, Sanjay. I actually like this idea. This is a cool idea. We could use range with a step that Leah proposed right now to create a list of those numbers. We would just need to do list range. And then, like you said, use random choice to pick one of them each and every time. So excellent idea. Flora, I see you used your own version for delay. Cool, whatever works for you. There are many different ways you could do it. So I like yours as well. So if there are no more questions,
I have a couple of questions.
Sure.
So,
sure.
Okay, so I have a couple questions and a couple comments. So first of all, in regard to Flora's delay, I like that because basically I think the way that she's written it, it prevents the delay from going negative. Okay. Because if you just keep on subtracting the delays without setting.
I'm not subtracting, I'm multiplying. I'm multiplying by 0 of 95, so that would never go negative.
Okay, but you could also subtract. And then if you subtract, okay, it could, in theory, eventually go negative. And so the way that Flora wrote it here, it prevents it from going negative. And then I have one comment and one question. So what I didn't quite understand is if you're detecting collision with the snake and the goal, okay? Even if your goal is not quite matched up with the snake, I think there's a command you could just kind of detect if there's more than one object within a space, right?
Yes.
And so if you use that command, why does your goal have to be in sort of increments of 20? Because
it doesn't.
theoretically, if your goal, spans those 4 squares, right? As long as the snake gets into any of those areas, okay, in theory, that would count as a collision.
I agree, and the reason why I'm doing it the way I'm doing is my personal preference. So there's nothing wrong with actually checking for a collision using the. I don't remember the method right now. It's like check collisions or whatever. You could do that, and then
I think it's called find overlapping.
Find overlapping. Yeah, thanks, Irene. So yes, you get a list of, I think, objects that are overlapping in that specific set of coordinates. And you could check if it's, more than a certain amount or equal to a certain amount, then, you could say that the goal was reached. Or you could actually look for that specific object in that list. Say, if goal in that overlapping list, then yes, we're done. So that would definitely work. I'm not saying it's wrong. It's another way of doing it. The reason why I'm doing the way this is because I'm thinking of the original snake, which actually worked in pixels. So it couldn't move between pixels. It has to move pixel by pixel because the resolution of the screens in those days were 128 by 60. I don't know. The screens were very small and low resolution. So there were no in-betweens. They were the way they're drawn right now on the screen. But otherwise, good comment. You could do it differently.
And then I believe, okay, correct me if I'm wrong, there's another way of checking overlap. You could actually check overlap. Wait, wait. So well, the way that Irene mentioned of find overlap is one way.
Yeah.
But I thought there was another way, like okay, maybe not. Perhaps I'm just like hallucinating. And- okay, never mind. Uh I did it using yeah, yeah, yeah. Yeah. So no, no, no. Forget it. Okay. I also did it using the find overlap. And then one other comment is when you're doing this random division by 20, okay, the way that I wrote it, and then I'm just wondering if you could kind of comment on this. I basically had a while condition. I said like, while the random x division by 20 does not equal to 0, or the random y division by 20 does not equal to 0, okay? And then I will have it pick like a new random x and random y until that condition is satisfied. Okay. However, um, I was a little bit conflicted as to whether or not I should use an or there or an and there. I tried it both ways, and then the program actually ran both ways. But I think
My feeling, do I understand correctly that you're talking about not integer division by modulo
yes,
division, like the remainder? Okay,
yes.
I think it should be and to make sure that it's both horizontally and vertically aligned with the grid.
Well, I tried both ways. It worked both ways, but I'm pretty sure both ways cannot be correct. And then I was actually, okay, originally I was thinking like, okay, maybe it should be and, but well, um, I'll just like type the command in the chat so that you can take a look at it. Um, but when I like thought about it, I think it should be or, correct? Um, because if I were to use an and, if
But
either one of these conditions
you're using not equal.
not right,
That's the
okay,
reason why you need or.
okay. And so the way that I have the or is correct here.
It looks this way, yes.
Okay. Yeah, okay. So, I actually finished all of the extension except the full snake, and so I can post the code, on the Google Drive, later.
Okay, sounds good. So with this code, I will also post it, and you can try playing around with it, trying to do the extensions yourself. Obviously, like I said, if there are any questions that you have, between sessions, post them on the forum, mark them with the LACIP. We'll try to look at them and answer them promptly. And I think we've had enough for today. Once again I talked too much. Once again I ran 25 minutes over, but I think this time it was worth it finishing at least with the basic baby snake. So once again, next week in a week it's going to be NumPy with Chris. In 2 weeks I'm going to return. We're going to do pop-up shop and breakout. We're probably not going to finish breakout in time, given it's more complex than
We're gonna
baby.
finish, okay? I mean, you're
But
getting faster every
I'm
time. We're
going
gonna
to
finish.
try. Okay, so that's that for today, ladies and gentlemen. Thank you for being with us. Unless someone has any other questions that need answering, See you for me in 2 weeks, with Vicky in a week. Yeah.